Hello everyone, my name is Khushi Pendari. So today's webinar topic is about autonomous construction and AI-driven infrastructure resilience. So in that webinar, we have to see why autonomous construction industry is required for the modern civil engineering infrastructure, as well as the why AI techniques have to be used in the modern infrastructure resilience. So first of all, we have to be discussed about the agenda of our webinar. Agenda means about the introductory part or what kind of parts we have to be seen in that webinar. So first is about the introduction. Introduction about the autonomous construction industry. After that, autonomous construction technologies means which construction technologies that we have to be used in a modern civil infrastructure or a smart infrastructure. After that, AI in infrastructure resilience means what is the use of AI in our new infrastructure resilience. After that, smart sensing as well as the monitoring, like how smart sensing as well as the monitoring is works. Then tools and AI frameworks as well as the applications and the case study on it, and the challenges as well as the future scope of it. Means what are the challenges that we have to be faced and what are the case studies that had been done in a past few years. Then we will be conclude the session. So first of all is about the introduction about the autonomous construction and AI driven infrastructure resilience. So in that, rise of AI in civil engineering. AI is used in different domains like in computer science, AI, ML. But we are now we have to be used that AI in our civil industries. So artificial intelligence has become one of the most transformative technologies in the civil engineering over the last decades. Uh, that what started as a basic automation, such as using spreadsheets or a simple simulation, that has to be involved into a data-driven engineering, where AI modes can be analyzed thousands of variables simultaneously and provide a precise predictions. First is AI in planning and design, like why AI is used in a planning as well as in the designing purpose. AI algorithms analyze soil data, load conditions, materials, as well as the climatic factor that are affecting on our structural design. Then generative designs, that are the tools uses in AI to create hundreds of designs that varies based on the constraints like cost, material availability, safety, as well as the sustainability. Structural optimization ensures minimum material use without the compromising their strength. After that, AI in construction management. AI powered planning tools can predict delays caused by the weather, resource shortage, as well as the labor issues. Smart scheduling automatically adjusts project tasks to reduce the delays in our project. AI monitors real-time site progress throughout the drone imagery as well as matches it with the BI models. Then AI in quality control. Computer vision algorithms identify the cracks, misalignments, surface defects, as well as the rebar spacing errors in a real-time monitoring. Automated inspection ensures faster detection of a construction defects. It will be reduce the rework as well as the cost. AI and digital twins. Digital twin technology creates a virtual replica of the infrastructure that updates with the real-time sensor data. Engineers can simulate future scenarios, stress conditions, and deterioration patterns. Data-driven decision making. AI provides engineering insights based on the large data sets that humans cannot manually compute. That will be helps in resource forecasting, structure performance prediction, and long-term asset management. So that are the uses of the AI that are it is no longer optional. It has become a core pillar for a modern civil engineering that will be shaping the future of infrastructure as well as the development. Automation improving safety, cost, and the speed. Automation in the construction industry includes robotics, autonomous equipments, automated inspection system, and the intelligent project management software. Safety improvements throughout the automation. Construction is one of the most dangerous industry. Automation significantly reduces the human involvement in the risky tasks, like robotics for the hazardous environment. Robots can perform the welding, demolition, tunnel boring, as well as the heavy lifting with the high precision. Autonomous excavators and the bulldozers can operate in the dangerous terrain as well as the unstable environment. Drones for the inspection and the surveillance. Drones can survey all the tall structure. It will be give a deep excavation and inaccessible areas, as well as it eliminating the risk for the human inspectors. Then thermal cameras to detect the overheating, fire hazards, and the electrical failures in the structures. After that, air safety monitoring. AI system detect unsafe worker behavior, like someone is not using PPE, like protective equipment, just like a mask or glues or any kind of things. That AI will be monitor and detect which people cannot be uses that kind of things. After that, cameras continuously scan the hazards like excessive dust, unstable scaffolding, and the unauthorized access. Means there should be a scaffolding is unstable while plastering or a building infrastructure that will be hazardous for the workers as well as for the uh, humans on the site. Next one about the cost reduction through the automation. Elimination of rework. Automated machineries ensure the precise execution with reducing human errors that often lead to expensive corrections. Means it will be eliminate the rework. Suppose they are finding out what are kind of the work, it would be rework and they will be eliminate that. Then optimize the resource utilization. AI predicts exact material quantities as per the needed of our infrastructure. It will be reduce the waste as well as over ordering. Automated logistics ensures timely delivery of the material, lowering the storage as well as the downtime cost. After that, efficient labor use. Means it will be automationally free human workers for the skilled task rather than repetitive manual work or the labor work. Productivity increase while labor cost decreases. Then faster construction through the automation. Continuous operation. Autonomous machines can work 24 by 7 without any fatigue. Like people cannot be worked 24 by 7. There should be a decided duties for the 8 hours, 9 hours, 10 hours. Rather than that, they can't be worked. But if you are working with the robotics or with the autonomous machinery, they can work 24 by 7 so that your work should be a seamless. After that, real-time tracking. Drone mapping complete the site surveys in a minute, not in a days. Means drone tracking for the surveying or for the making new site, we can be tracked by the drones as well as the new surveying instruments, and that will give a less time for our project or to complete our project. AI compares real-time progress with the project schedules and automatically updates the timelines. It will be reduce the construction delays. AI predict and resolve the conflicts before they appear in the construction sequencing. Like automation ensure the faster, safer and more cost effective and making it essential for the large scale modern infrastructure. And last one is about the infrastructure resilience through the predictive analysis. Infrastructure resilience means the ability of the structure to withstand external stresses, aging and unexpected events while maintaining the functionality. Predictive analytics uses historical data, sensor data, machine learning, as well as the environmental monitoring to forecast how infrastructure will behave in the future. Early detection of the structural weakness. Sensors embedded in the bridges, dams, roads, as well as the buildings collect the data on their vibrations, stress or strain on the bridges or the dams, moisture on it, temperature, as well as the crack propagations. Means it will be find out what are the going to be structural weakness or the early detection before the actual crack or fatigue should be happens on a structure. AI model analyze this data to identify the abnormal pattern before they turn into the failure, because AI should be giving us to what kind of failures are to be happens in our structure or in our infrastructure. They predict the long-term deterioration. Machine learning models estimate the corrosion rates, fatigue life, concrete degradation, asphalt aging, steel enforcement weakening. Climate risk assessment. AI models simulate how structures behave under different climatic conditions like flood, extreme heat, heavy rainfall, earthquake, and the windstorms. Then smart maintenance scheduling. Traditional maintenance is the time based, like it will be giving a 3 or 4 years. But predictive analytics shifts the condition based maintenance where repairs occur only when they are to be needed. Like it will be giving a lower maintenance cost, fewer sudden failures, as well as the long asset life. AI powered decision system. AI prioritizes which infrastructure needs attention based on the risk level, public importance, as well as the failure probability. After that, resilience in the smart cities, like IoT sensors, AI dashboards, autonomous inspection doors, and the real time warning system. This creates a connected network of the resilient infrastructure that are capable of withstanding the future challenges. So this is how AI or AI-driven techniques that we have to be used in our infrastructure for the automation. What is the autonomous construction industry? So this is what we have to be seen in that. Like what is a main autonomous construction industry? which we have to be seen. So predictive scheduling models, AI-based project planning give us a predictive scheduling models that uses AI as well as the machine learning to forecast how a construction schedule will be progressed based on the past data, real-time updates, and the project conditions. How it works, AI analyzes historical project data such as the delays, productivity rate, weather impacts. It monitors real-time site progress through the IoT sensors, drones, and the equipment logs. It will be based on the patterns to adjust the schedules, future delays, as well as the estimation and the completion dates. So how it predicts which activities might be get delayed, how long tasks will be actually take, impact of the weather, resource shortage, equipment breakdown that they had to be predict using the AI based project planning. Like we are manually doing a project planning, so that is the main difference between the AI project planning as well as the manual planning. Risk-based planning. Risk-based planning means AI algorithms will identify, analyze, and mitigate the risk throughout the project lifecycle. Like it will be analyzed as well as the mitigate risk. So, which type of risk can be faced? Cost escalation, unknown site conditions, safety hazards, contractor delays, procurement delays, as well as the weather distribution. After that, optimize the resource and the cost allocation. AI ensures that the labor, material, machinery, and the budgets are utilized in the most efficient way to minimize the waste and reduce the cost. Like AI will be optimized through different types of methods, and they will be optimize the cost. AI optimized. Labor use, assigning workers where productivity is the highest. After that, material planning, which avoiding the shortage and the unnecessary stock. Then equipment allocation, which ensures the machinery as well as the about how it works and the cost estimation. So this is what it will be do in the technology. Then self-driving construction vehicles, like how the autonomous construction works. So first of all, they are using self-operating or self-driving construction systems or the vehicles. Self-driving construction vehicles or the machineries or the system is can navigate, operate, and perform the task automatically without direct human control. These rely on the AI, LiDAR, GPS, cameras, as well as the sensors to understand the environment and execute the work safely. GPS and LiDAR mapping. Create a 3D model of the site for the navigation. Camera and sensors. It will be detect the obstacles, workers, and material piles. AI softwares that will be plan the routes, control speed, as well as make safe decisions. So what are the examples of it? Autonomous dump trucks for the earth moving, self-driving loaders for the load compaction, automated skid steel loaders, autonomous dozers for the grading. So this is how they are working. What are the benefits of it? It will give a higher precision in the excavation, leveling, as well as the material movement. It will be continuous 24/7 operation. It will reduce the labor requirements. It will improve the safety by keeping the humans out of the hazard zones. So this is how uh, autonomous or self-operating construction system works. Then robotic machinery controlled by the AI, like robotic arms for the excavation or the assembly. Or robotic arms perform repetitive or the dangerous or highly precision tasks on the construction sites. These arms can be controlled by the AI, computers, vision, as well as the BIM-based instructions. So this is how we can see how they work. AI analyzes the building model or the excavation plan. Robotic arms can use accurate joints to move with the higher accuracy. Sensors provide real-time feedback on the load, position, alignment. Computer vision ensures the correct placement of the material or the tools. So what are the applications of it? Excavation, precise trenching, soil removal, tunnel excavation, assembly, lifting, placing, fastening structural components, rebar tying, automated reinforcement placement, welding and cutting, robotics fabrication and the steel structures, bricklaying, robots can capable of laying the thousands of brick per day. So This is how it works. What are the benefits of it? It has a higher accuracy and the repeatability, faster execution of the repetitive task. It will minimize the human involvement in the dangerous or heavy operations. It supports the complex geometries and not easily handled by the manual labor. So this is how they are giving us AI based planning, like how we can do this. We can predict the schedule models, we can risk based planning using the ML, we can optimize the resource and the cost allocation. Then autonomous machinery, which kind of machinery are used, that we had to be seen, like self-driving construction vehicles, robotic arms for the excavation, then or the drone assisted coordination. Means what? Drone enhances the site management, monitoring and the coordination by capturing the aerial data and the providing real-time insights. So we have to be seen how they work. Drones captures higher resolutions videos, 2D maps and the 3D models. GPS and algorithms helps drones to allow a pre-propagated flight paths. Data is processed to generate the progress reports and detect issues and optimize the logistics. ML tools automatically compares drones images with the designs model, just like a BIM. So what are the applications of it? First of all is about the progress monitoring, means it will be tracking the daily as well as the weekly activities for the site development. Then material tracking, identify where material are stored and needed. Then safety monitoring, it will be detect the unsafe zones, workers, PPE violation or the hazards. Then surveying and the mapping, fast mapping of a large or a complex terrain. Then logistic coordination, it will be guides the movements of the vehicles as well as the equipments. Next we have to be seen about the AI for the material optimization, means for the material optimization, how we can use the AI. So in that, AI assisted material selection means what? It will give you information about it, helps engineers as well as the contractors to choose the best material based on the cost, performance, durability, environmental impact and the project requirement. Means AI will be suggested you about the best materials to according to your budgets, your cost, your performance as well as the durability. So this is how we seen how it works. AI analyzes database of a material properties like a strain, density, thermal resistance, life cycle. It compares the material options with the project needed, like a load bearing, weather exposure, sustainability goals. Then it uses optimization algorithms to recommend the best material combination. Then it will be considered cost, availability, safety standards as well as the IL standards. What are the applications of it? Selecting the ideal grade of a concrete or a steel for the load conditions. Choosing eco-friendly materials to meet the green building standards. Then identifying the alternatives when primary materials facing issues for the supply ship, or whenever the primary materials are getting shortened. So we have to be seen what are the alternative materials that we have to be used instead of it. Then suggesting composites, admixtures or the high performance material. Then we will be seeing what are the benefits of it. It will be give a better quality as well as the longevity, cost-effective selection, faster decision making, reduce the risk of a material failure, and improve sustainability. Then real-time quality checks. AI-powered sensors, cameras, and the scanners conduct continuous quality monitoring of the materials as they are delivered, stored, or used on a sites. Then how it works. Computer vision detects cracks, deformity voids, or color changes in a material. IoT sensors measures moisture, temperature, strength, and curing conditions. AI compares real-time data with the design specification as well as the quality standards. Alerts engineers immediately if defects or the deviations are found. What are the examples of it? AI scanning concrete surface for the honeycombing or the cracks. As we all know, the honeycombing and cracks are dangerous for the structures. For AI will be scan the concrete surfaces and detect it. Then checking the steel reinforcement alignment using the image recognition. Using a image recognition, you can see what are the steel reinforcement or the misalignment has been happening in our structure after some year of building, as well as monitoring curing temperature of the concrete using sensors. Verifying dimensions and the tolerances for the prefabricated elements. Early detection of a quality issue. reduction in rework, better compliance with the standards, improved site safety. And last one is about it will be reduced the wastage using the predictive models. Predictive AI models analyze huge patterns, project progresses, and a supply data to minimize the material use. How it works: AI predicts exact material quantities based on the BIM and a project data. It will be tracks material consumption in real time and forecasts future demand. It identifies areas where wastage is high and suggests corrective strategies. It optimizes cutting patterns like a steel, tiles, timber, as well as the frameworks to reduce the scrap. So, what are the applications of it that we have to be seen? It will be prevent over ordering of the cement or the steel or the aggregate or a brick. Like if you are working on a site, we will be ordered different materials in a different quantity. If you know about the predictive models, then you will be minimize the wastage. Predicting material shortage and avoiding emergency purchases. Like someone is ordering some one place, and at any time there will be a shortage. You can material shortages you should be predicted, and you have to be avoid the emergency purchases. Optimizing concrete batching to avoid the leftover mix. It reducing the scrap through intelligent planning of rebar cutting or a tile layout. What are the benefits of it? Lower project cost, less leftover or damaged materials, better inventory management, and increase the efficiencies with sustainability. Next one is about the infrastructure resilience. AI prediction of a structural failures. AI significantly enhances infrastructure safely by predicting when and how structure failures may occur. It uses real-time monitoring as well as the machine learning models to identify the early warning signs that humans may miss. How AI predicts failures? First one is about the sensor-based monitoring. Structures are occupied with the sensors that measure the strain, displacement, crack, stress, distribution, corrosion levels, as well as the vibration and the temperature. Machine learning algorithms. AI study patterns in a historical failures and compares them with the live sensors data to detect the anomalies. So, about the failure pattern recognition is also find out the failure patterns that are happening in our structure. So, next one is about the climate risk modeling. Infrastructure is now exposed to extreme weather and more frequently like floods, heat waves, cyclones, as well as the sea level rise. AI can help to predict the climate impacts on the structure across their life cycle. Like how it performs, it integrates the global climatic models with the local environmental data. It uses 50 to 100 years of historical weather data. It simulates how structure behave under heavy rainfall and a flooding, extreme heat, cyclonic wind floods, as well as the fizzing and thawing. It will predict the future risk zones for the roads, bridges, buildings. It provides a risk maps for the flood prone areas, landslide areas, or the heavy wind corridors, like that. And last one is about sustaining long-term durability. AI not only predict the failure but also helps to enhance the long-term service life of our infrastructure. AI enable durability optimization. Material performance prediction. AI models estimate how concrete, steel, composites, or a new material degrade over the time. Optimize the material mix design. AI recommends low permeability concrete, supplementary cementitious materials, corrosion resistant environment. Life cycle cost and the performance modeling. AI calculates maintenance intervals, rehabilitation needs, cost effective durability enhancement. And after that, long term benefits of it is about reduced maintenance cost, better planning of the rehabilitation cycle, increase the safety as well as the reliability. So next one is about the predictive maintenance. Predictive maintenance is a modern infrastructure technique that we have to be used. Like it will predict how which kind of maintenance that we have to be done in a smart infrastructure. So first one is about the sensor driven monitoring. Modern infrastructure uses IoT sensors to continuously track the structural health of a bridges, roads, tunnels, as well as the high-rise buildings as well as the dams. These sensors collect real-time data and send to a cloud-based AI systems. The types of sensors used are strain gauges, it will detect the stress and the deformation. Accelerometers monitor vibration and dynamic responses. Crack sensors track the macro as well as the micro crack growth. Corrosion sensors detect the reinforcement deterioration. Moisture or a temperature sensor that will be track the environmental loading. How sensors monitoring works? Real-time data is captured 24 by 7. AI automatically identifies the anomalies or a abnormal structural behavior. It alerts are generated before a serve damage occurs. What are the benefits of it? Detects hidden defects early, reduces inspection cost and manual errors. It enables the continuous monitoring and a critical infrastructure. AI risk scoring of the bridges, roads, and the buildings. AI assigns risk scores of an infrastructure based on the conditions, environment, traffic loads, or the deterioration patterns. So, how it works or how AI is analyzed? It analyzes the sensor data, historical failure records, material degradation rates, weather and climate impact, traffic density, and loading cycles. Application bridges. It detects the fatigue, corrosion, deck cracking, expansion joint failure. Roads evaluates the payments, distress, routing, subgrade moisture movement. What are the outcome of it? Government and engineers prioritize repairs based on the risk rather than the guesswork. Life cycle forecasting. AI forecast future performance, maintenance needs, and the rehabilitation schedules over next 10 to 50 plus years. Life cycle forecasting includes degradation curve prediction. AI models how components like a beam, slab, pavement, or the foundation will deteriorate over the time. Maintenance timelines, minor repairs, major rehabilitation, or the replacement. While life cycle forecasting is important, it extends the life of our infrastructure, it reduces the life cycle cost, it eliminates the unexpected failures, it supports a long-term asset management plans. Then we have to be seen the main part about the structural health monitoring. Structural health monitoring is about a technology that driven process used to continuously assess the conditions, performance, safety, infrastructure such as a breach, building, dams, tunnels, and the towers. What are the key objectives of it? It detects the early signs of the damage. It reduces the maintenance cost. It increases the lifespan of the infrastructure. It enhances the safety as well as the risk mitigation. So, structural health monitoring uses sensors, data acquisition system, and the analytical models to predict the structural performance and identity failures before they actually happens on a structure. So, vibration analysis is one of the method. So, it is one of the most widely used technique in structural health monitoring. So, we have to be seen how it works or what it does. It monitors the natural frequency, mode shapes, damping characters of the structures. It helps to predict the structural failures throughout the dynamic response patterns. Why it matters? Any reduction in a natural frequency indicates a loss of a stiffness. Abnormal vibration signature indicate the structural or machinal faults. Next one is about the deformation and a crack detection. This focuses on identifying physical changes in the structure's geometry. Deformation monitoring tracks vertical or horizontal displacement over the time. It detects settlement, tilting, bending, or a deflection beyond a safe limits. It uses sensors like laser scanners, total station, GNSS. Crack detection identifies size, length, depth, and propagation rate of a crack. Uses AI-enabled visual images, strain gauges, optical sensors, and the inspection. It will be early crack detection and it will be prevent the collapse. And last one is about the IoT enabled structural sensors. IoT based structural sensors that how it works that we have to be seen. Sensors collect real time structural data, vibrations, strains, temperature, stress, corrosion, rate as well as the displacement. Data is sent through the wireless networks to the cloud sensors, AI/ML algorithm and analyze the patterns and predict the failures. What are the benefits of it? 25 by 7 remote monitoring, automated alerts during the abnormal condition. It will be reduced a manual inspection workload, high data accuracy and long-term reliability. Examples of IoT sensors: strain gauges, accelerometers, fiber bridge gating, ultrasonic crack sensors, corrosion sensors, smart rebar with the embedded chips. Next one is about the drones and the LiDARs. High resolution terrain mapping. Drones equipped with the LiDAR, like light detection and ranging, it provides extremely accurate and a high density terrain data. How it works: LiDAR sensors emit laser pulse towards the ground. The sensors measures the real-time taken data. Millions of the points are collected in a single rate, or the 3D cloud model. Drones can cover the large and inaccessible area quickly. Key advantages of it: it will be give a centimeter level accuracy for the topographical surveys. It penetrates the vegetations, ground elevations and the models, as well as it's ideal for the cut field analysis, route alignment and the site planning. It's faster and cheaper than a total station. Highway and railway alignment, land development planning, river, dam and floodplain mapping, mine surveying and volumetric calculations. Automated progress reporting. Drone automates site monitoring and reporting through the aerial imaging and AI-based analytics. What it involves is scheduled drone flights, captures day-wise and week-wise site images. Software converts 2D or orthomaptic maps, 3D models of the construction site, volume estimate, work done comparison with the project schedules. So what are the benefits of it? It gives a accurate process tracking, it reduction in human errors, it improves the transparency. Why it matters: automated drones reporting improves decision making, reduce delays, enhance the accountability on large construction sites. Then last one is about the structural scanning of for the defects. Drones with the LiDARs, thermal cameras, and the high resolution for the imaging are used to detect the structural problems quickly and safely, as well as type of defect drones can identify: surface cracks, spalling, declimation, corrosion on steel structures, moisture intrusion, joint failure, misalignment, pavement distress, footholds, routings, roof damages, and facade cracks. So that are can be analyzed in the drones and LiDAR. Then next one is about real-time monitoring system. It is continuously track the conditions, performance, and the safety of a civil infrastructure using the sensors, communication networks, and the analytics platforms. They allow engineers to identify the problems instantly and take action before damage escalates. IoT and cloud connected devices. IoT devices are embedded sensors that measure structural and environmental parameters. Then they transmit the data instantly to the cloud servers for the analysis. How they work: sensors monitor parameters like strain, vibration, temperature, humidity, or displacement, tilt, stress, and the crack width. Wireless communication like Wi-Fi or LoRa, then cloud platforms store, visualize, and analyze the data using AI and machine learning. Benefits of it: no need for the manual data collection, high frequency data capture, centralized storage, accessible everywhere. It supports the predictive maintenance and early warning systems. Examples of IoT sensors: smart strain gauges, accelerometers, fiber bridge sensors. Then instant alert system. Instant alert system notify engineers or the authorities immediately when abnormal structural behavior is detected. Sensors readings exceeds the predictive safety thresholds. Sudden changes in the vibration, stress, or the displacement. Rapid crack propagation. Excessive tilt, settlement, or a temperature rise. Water levels or the load increasing beyond the safe limits. Then alert channels about the SMS, mobile app notifications, email alerts, alarms in the dashboards, or the automated voice calls. So this is how the instant alert system is worked in a real-time monitoring system. And last one is about the remote monitoring dashboards. Dashboards provides a real-time visual interface for the engineers, project managers, algorithms, and the monitor infrastructure health from anywhere. Live data stream, vibration, strain, deformation, load, temperature. Color coded risk level like yellow, green, red. Inactivity, 2D or 3D models or a digital twins. Automated reports and the analytical. Historical data and comparisons for the tools, maintenance scheduling, and the alerts panel. What are the benefits of it? Full transparency and easy interpretation for the structural conditions, remote access from the mobile, tablet, or the desktops, supports the multi-site monitoring, bridges, buildings, dams, tunnels. It helps in the planning, maintenance, and prioritizing the repairs. And the last one is about the Python or in a civil analytics. It will be about the risk modeling, like it is a AI driven technique used for risk modeling. Risk modeling uses historical, statistical, probabilistic, or a machine learning techniques to evaluate the likelihood and convenience failures in the infrastructure system. So how it works? It will give you a predictive deterioration modeling for forecast how the structure degrade over the time based on the material behavior, environmental exposure, and the loading conditions. Then data driven decision making, like how data driven decision makings can be done in that. Python can help to convert the raw data from the sensors, surveys, and the inspections into actionable insights. So what are the capabilities of it? Data cleaning and pre-processing, then advanced visualization, optimization models, clustering analysis, AI powered dashboards. So, what are the applications in civil engineering? It will be prioritizing which bridges or roads needs immediate repairs, optimizing machine or the maintenance budgets, scheduling construction activities, selecting material based on the performance data, assessing structural health from the IoT sensors data. So next one is about the case study of the smart bridge. Modern bridges are increasingly equipped with the intelligent monitoring system that integrates IoT sensors, AI analytics, and the cloud platforms. This case study demonstrates how a smart bridge uses real-time load monitoring, AI-based anomaly detection, and the automated maintenance alerts. Real-time load monitoring. So, system overview. The bridge occupied with the network of sensors, which includes strain gauges, weight in motion, as well as the accelerometers, and the temperature and humidity sensors. These sensors can continuously stream data to a cloud server as well as enabling instantly assessment of a structural behavior. What it tracks: live axial loads and vehicle categories, load distribution across the girders and the piers, stress variation during the peak and off-peak traffic. What are the benefits of it? It ensures the bridges is not overloaded. It detects the abnormal stress pattern. It helps to authorize the enforce weight regulation. It reduces the wear and extends structural lifespan. AI anomaly detection. How AI is integrated. AI algorithm analyze millions of the data points collected daily from the bridges. It will be random forecast for the classification of the load patterns. It will be give a clustering models to find out the unusual load or the stress behavior on it. What AI detects: sudden changes in the structural stiffness, abnormal vibration frequencies, excessive stress during the specific goal, temperature corrected material that are to be analyzed. Why it matters? It detects early stage damage invisible to the naked eye. It provides it provides the data driven risk scores. It enables the predictive maintenance decision. Automated maintenance alerts. Alerts tracking condition. The system automatically generates alerts when strain exceeds safe thresholds, abnormal load events occurs, vibration patterns deviate from the historical norms. So this is how they are giving a alert delivery. Then automated actions, immediate traffic diversions during the extreme condition, scheduling on-site inspection, activation of structural support system, generate maintenance tickets in the CMMS or computer maintenance system. Rapid response reduces structural risk, eliminates manual monitoring dependencies, optimize maintenance and the budget with the predictive insights. What are the outcomes of the smart bridge system? 20 to 30% reductions in the maintenance cost, 50% fast detection, real-time decision making. So what are the challenges that we have to be faced in that? So high setups cost. IoT sensors constantly sends real-time data. Why? Like high setup cost is what? Advanced setups like a LiDAR, strain gauges, fiber optic accelerometers are expensive. Installation requires by the specialized drilling, cabling, calibration on a site shutdown, cloud storage, data processing platforms, and IoT gateways for the data-driven techniques. Budget constraints delays adoption in a small or a medium scale projects. Difficult for developing region to implement large scale monitoring. It requires a long-term financial planning, not just initial cost. Possible mitigation. Government subsidies using the SCADA's modular monitoring system phased implementation. Data-driven or a cyber security. Key ask is like IoT sensors constantly send a real-time data about the infrastructures. After that, cyber security challenges, securing thousands of distributed sensors, protecting Wi-Fi, LiDARs, as well as the also prevents the unauthorized access to the dashboard, ensuring the encrypted data storage. Then requires solutions for the storage, encryptions, and multi-factor authentication. They are happening. Skilled manpower required. It is the one of the most challenge in our civil infrastructure industries. Engineers must understand the sensors, electronics, AI, machine learning, and cloud platforms. Technicians must manage about the installation, calibration, and the maintenance. So this is how that are the kind of challenges that we have to be faced. Future scope. Fully autonomous construction ecosystem. It means future construction sites will operate within a minimum human inventions using AI-driven techniques. Autonomous machinery, self-driving excavators, girders, dumpers, like that. What are the impacts of it? It reduces the human errors. It increases the safety by minimizing risk, manual tasks, faster the project delivery, and improve the accuracy as well as the quality control. Then advanced predictive infrastructure models. Next generation models will predict how infrastructure will behave decades into a future using AI, big data, and the sensor-based feedbacks. Technologies involve AI deterioration forecasting for the breach, payments, and the buildings. Real-time structural digital twins for the continuous health assessment. Material level prediction models, climate adaptive simulations, probabilistic risk models. Benefits. It extends a service life through the productive maintenance, automatically identifies future hotspots of the failures, optimized budgets and reduce the life cycle cost, enhances the disaster as well as helps policymakers to plan long-term data. Next generation resilient smart cities. What future smart cities will look like? Cities will be fully interconnected, adaptive, and capable of responding to environmental, structural, as well as the operational issues in real time. Hyper-connected infrastructure, AI disaster response system, energy efficient green building, autonomous transportation networks, urban digital twins, climate resistant designs. So that are the kind of next resilient smart cities. And then we have to be conclude the session, like we have to be seeing which kind of things are the point that we have to be discussed. So in that, artificial intelligence is rapidly transforming the construction as well as the infrastructure industry by enabling the smarter, faster, and more reliable project delivery from the structural health monitoring. Drone based surveying and predictive analytics are autonomous machinery. AI is reshaping how civil engineers designs, build, and maintain the built environment. Automation significantly enhanced the safety, accuracy, and efficiency. It reduced the human errors, minimizing the risky site activities, real-time monitoring system, IoT sensors, and the AI-driven techniques throughout their life cycles. Looking forward, civil engineering is moving toward the future where infrastructure is intelligent and inadaptive is highly ensured the resource efficient, fully autonomous construction ecosystem, predictive infrastructure models, and the resilient smart cities will define modern infrastructure as well as the engineering, making infrastructure safer, greener, and more respectful to the environmental and the social needs. So this is how that we have to be seen in that session, that which points that we have been discussed about why AI is important in modern technologies or in new technologies that we have to be seen. So this is how AI is important for our infrastructure in modern era or in a modern technology. So that we have to be conclude the session. Thank you.